surge tanks are discussed in detail in the book Surge Analysis and the Wave Plan Method by Drs. Lingaretti and Wood on page 95. We'll assume at this point that you have a model with a good steady state analysis and also a surge event such as a shutdown or a pump trip. In this case, we are tripping all three pumps. And we'll further assume that there are high and low pressures or even cavitation that may need to be addressed in the model. And here are our model results. When adding a surge tank, location is important. Sometimes there are site limitations, but generally a surge tank should be placed as close to the pump station as possible. Click on the pipe close to the pump station. Go to Insert, select Other, and the full node list appears. Select Surge Protection Device. Now under Device Type, select Closed for a closed surge tank. We do need to input an elevation. The elevation of the nearby node is 550, so I will enter 550. Elevation is the center line of the main pipe to which the tank is connected. Click on Device Help for a quick reference for definitions, units, and geometry. If the tank is located significantly higher than the pipeline, you may account for this elevation difference here. We'll say there is a difference of 2 meters. Next, estimate the initial tank volume and the initial gas volume. Initial gas volume is one of the parameters that is most significant in surge tank performance. A common assumption is to start with 50% air, keeping in mind as you test various tank setups that it is ideal to stay above a 20% water level during the transient event low pressures. But what tank volume should you start with? It is easy enough to select a volume that seems logical and simply run multiple surge analyses, trying different tank volumes iteratively. However, a rough idea of the required initial air volume can be estimated based on the initial pipeline flow and the overall length of the pipeline to other storage facilities. If, for example, the initial flow is 1000 GPM, and we know from the pipe length and wave speed that it takes 30 seconds for wave reflections to return to the pump, you may want to size a surge tank to provide 30 seconds of flow, or 500 gallons. However, it is very easy to simply vary the initial gas volume until you get an acceptable transient response. Tank volumes are entered in cubic feet or cubic meters. Expansion constant is usually 1.2. The range is 1 to 1.4, with 1 being adiabatic and 1.4 being isothermal. Enter the diameter of the tank here. Note that closed surge tanks can be horizontal or vertical, or variable, and that the diameter for the tank is the circular cross-section of the tank regardless of the orientation. It is recommended to always use this option to calculate initial level using this checkbox. Notice when I check this checkbox that the input for initial level will go away. If you want to model a hybrid tank, this box will be checked, but we'll stay focused on a typical closed surge tank in this video. The last inputs are inflow and outflow resistances. With the tank node placed directly in the main pipe, these resistance values are used to represent the connection of the tank to the main pipe. Resistance affects how rapidly liquid enters and leaves the tank, and therefore these values, along with the initial gas volume, are critical to the tank's performance. Calculate resistance using a resistance calculator tool in the Tools menu. Select the units, and then select to calculate the resistance from a connection to tank. This guide pops up. We'll enter the number of elbows, 1, pipe diameter. Our main pipe is 900 millimeters, so we'll say the diameter of the pipe connecting our tank is maybe 300. And we'll say the length of the pipe is 3 meters. We'll compute the resistance, and we have a resistance of 9.7. Usually the inflow and outflow resistances are equal. There are some installations where there are different inlet and outlet pipes, and the resistances would be different values. Now we'll analyze the model and compare our results to the results without the surge tank. We've received this warning message, which tells us that our tank was not sufficiently large to avoid the gas volume exceeding the total tank size. So we should increase our tank size and try again. We get another warning. This time we'll keep our initial gas volume the same size and increase the tank volume. In order to compare the results with and without our surge tank, we'll run an analysis with the surge tank closed, and we'll compare the results. We'll pull up the pressure graph, and we'll select Display Previous Results so that both sets of results will be displayed simultaneously. We'll look at the pressures at this location. Here are the pressures without the surge tank, and if we click Previous Results, we see the pressure trace with the surge tank.